In previous lessons, we've multiplied fractions, but now we're going to do a little bit more of it, and we may have some simplifying or reducing. Now, when you're going to multiply fractions, one option is to simply multiply the tops, multiply the bottoms, and reduce your answer. But something that is easier is to look at the numerator of one and the denominator of the other, the numerator and denominator of the other, and then actually up and down. And what you're looking at in these directions is common factors that you can divide out. My nickname for looking in all of these directions before you multiply is to bow tie the fractions. And that's because the directions that you look actually create a bow tie. So here's what I'm talking about. I look at the 12 and the 27, and I know that 3 goes into both of those. So 3 goes into 12 4 times. 3 goes into 27 9 times. All right, so I've looked at this diagonal. Now let's look this way. Is there a common factor? Well, yes, this ends at a 5, this ends in a 0. 5 goes into 15 3 times. 5 goes into 20 4 times. Now what is overlooked many times is up and down now. 4 and 4, yes, 4 goes into itself once, 4 goes into itself once. 3 goes into itself once, 3 goes into 9 3 times. Now it gets cluttered, so you really have to see what you have left over in those positions and multiply now. Multiplying the tops, 1 times 1 is 1. Multiplying the bottoms, 1 times 3 is 3. Not only do you get the product, but it is already simplified. So I say bow tie before you multiply. You could have multiplied 12 times 15 and 20 times 27 and gotten rather large numerator and denominator and then worked to reduce it. But it is much easier if you look on the diagonals and up and down. In other words, always a top with a bottom to see if there are common factors. So let's see if we can bow tie before we multiply with these next few problems. All right, this one. I have 7/8 times 1/7. Remember, I'm looking this way, this way, this way, and this way. And what I see is on this diagonal, I see 7 goes into 7 once, and 7 goes into 7 once. On this diagonal, there's no common factor. Up and down, I have 1 and 8. I have 1 and 1. Nothing else divides out. Multiply the tops. 1 times 1 is 1. 8 times 1 is 8. I have the product, and it's in simplified form. Let's look at number 2. I have 7/6 times 1/7. The multiplication dot reminds me of the knot of the bow tie, so I know to look this way, up and down, up and down. Once again, I look at this diagonal and I see 7 goes into 7 once, 7 goes into 7 once. I look at this diagonal, I look up and down, I don't see anything else that I can reduce or divide out. 1 times 1 is 1, 6 times 1 is 6. Next one. I have 1/16 times 4/5. All right, let's look at our diagonals. 1 and 5, I don't see, there's nothing to divide out there. 4 and 16, yes. 4 goes into itself once, 4 goes into 16 4 times. If you had divided out 2 and gotten 2 and 8, you would divide again. So nothing to do this way. I divided this way. Nothing up and down, nothing up and down. 1 times 1 is 1, and 4 times 5 is 20. All right, let's look at number 4. I have 1/9 times 3/5. I'm looking this diagonal, up and down, up and down. And I see that 3 goes into 3 once, and 3 goes into 9 3 times. And that's all I can reduce. 1 times 1 is 1, and 3 times 5 is 15. Try to be neat so you can see what you have left. Number 5. 6/11 times 5/4. Looking on the diagonals, 5 and 11 have nothing in common, but 6 and 4 are both even. So 2 will divide into both of them. 2 goes into 4 2 times. 2 goes into 6 3 times. 3 and 11, nothing in common. 5 and 2, nothing in common. So I looked on both diagonals and up and down. I have 3 times 5 is 15, and I have 11 times 2 is 22. I have the product, and it's in lowest terms. The next one, I have 12/5 times 7/8. Looking on my diagonals, 12 and 8, yes. What is the largest thing I can divide into both of them? Well, that is a 4. So 4 goes into 8 2 times, and 4 goes into 12 3 times. 5 and 7 have nothing in common. 3 and 5, nothing. 7 and 2, nothing. So I'll multiply what I get. 3 times 7 is 21, and 5 times 2 is 10. 21/10. I am leaving these as improper fractions when need be. All right, the next one, I have a whole number. I am always supposed to change a whole number by putting it over 1. So now it is in fraction form. I'm multiplying that by 1/4. Looking on the diagonals, 4 goes into 4 once, 4 goes into 4 once. There's nothing else for me to divide out. I end up with 1/1, but 1 goes into 1 one time. These two numbers are called reciprocals. They are flips or inverses of each other, and the product of reciprocals is always going to be the number 1. All right, let's look at number 8. I have 3/7 times 7/3. I don't know if you notice it, but these are reciprocals again. The product needs to turn out to be 1, but let's see. Let's show it. Looking on this diagonal, 3 goes into itself once, 3 goes into itself once. On this diagonal, 7 goes into itself once, 7 goes into 7 once. Multiply, I get 1/1, which is 1. The product of reciprocals will always turn out to be 1. All right, just a few more. I have 1/6 times 54 will be written as 54/1. Recognizing that 6 goes into 54 is really good, so I hope you do know your multiplication facts. 6 goes into itself once, 6 goes into 54 9 times. When I multiply, 9 times 1 is 9, 1 times 1 is 1. I will not leave this because 1 goes into 9 evenly. I will instead say whole number 1. I'm sorry, whole number 9. All right, last one. I have 49, I'll put it over 1, times 3/7. Looking on my diagonals and up and down, I see that 7 goes into 7 once, 7 goes into 49 7 times. That's all I can reduce. Multiply 7 times 3 for 21. 1 times 1 is 1, and I get the whole number 21. Don't leave it as 21/1. My math lab will count that wrong. If you get a product with a 1 on top, that you have to show. But if it's on bottom, it divides in, and you can write it as a whole number. Okay? Do your bow tie before you multiply.